Hi, I thought I would do another one from Chapter 7 homework. This is just number 18 from your homework, but I think there's about 2 or 3 in the homework like this. And I thought this one was the best one because it also talks about the student T curve. Okay, so for this one, they're pretty much asking you, are you using the student T or the standard normal curve? That's what they're asking you in this section. The main difference between the two is T is what you use if you do not know sigma, the population standard deviation, which is most of the time, in all honesty. If you do know sigma, then you're going to use a Z value. Okay, now I gave you guys a copy of this, and it kind of talks about the two, if sigma's not known, sigma's not known, you're going to use a T value. You can either get that with inverse T if you have a near your calculator, or if you have the table if it's not on your calculator. And I'll do an example of that. If sigma is known, then you use a Z value. Okay. The other conditions that must be satisfied are listed right here. This is on page 29 in the PowerPoint. It's really hard to see this, but you could probably, let me see if we can make it a little bit closer so we can see it. Okay, wait for it to focus. There we go. Okay. So if sigma's not known, and this one says sigma's known, that's the two main difference between the two. The other conditions have to be satisfied regardless, otherwise you just can't do it. For both of these, they must be normally distributed population, or you have to have more than 30. Okay. If you have less than 30, it's not normally distributed. We just can't do it, in all honesty, from what we cover in this class. So just kind of think if sigma's known, you're going to use, if sigma's not known, you're going to use a T. If sigma's known, you can use a standard normal curve. Okay, so let's go back to this example. Okay, so it says, here's a summary statistics. It says N is 216, X bar is 30.5, and S is 7.6. Okay, so S is not sigma. S is a sample standard deviation from the sample of 216 girls, baby girls. We want to know, we don't know sigma. They don't give us this one. So since sigma is not known, you can use a T value. If sigma is known, you can use a Z value. Okay, so for this one, if this is a case, I'm just going to show you on here. If sigma is not known, you're going to use the T curve. You either use inverse T or table A3, which I'll show you today. If sigma is known, you're going to use inverse norm. And most of those, again, are on this page right here. So we're talking about this example right here. Okay, so sigma is not known. Okay, so I'm going to talk about how to basically get the answer. There's two ways. There's an inverse T in your calculator. Those are on the newer calculators. If you get 83, it's probably not on there. So there's another way to do it using the table. Okay, so the information we're given, the information we need is we need the confidence level, which was 95%. And the other thing we need to know is the sample size. Okay, so it's 95%. This is where we found our confidence level. This is our confidence level. This is how we find our critical value. So 1 minus 0.95 is 0.05, and that's divided evenly among each tail. The way we use inverse T, I put over here, is you put the area left and the degrees of freedom. The degrees of freedom is always n minus 1. So since n is 216, there'd be 1 minus, that'd be 215. Okay, so it'd be the area to the left, which is these two, and then the degrees of freedom. So I'm going to go ahead and show you this on the calculator if you have it. So again, the older calculators do not. So on the calculator, you're going to go in our second distribution, and it should be located there. It should be number 4 if your calculator does have it. And then you're going to put the area to the left, and the degrees of freedom, which is n minus 1. Okay, there's the answer. Okay, now let's say you don't have this on your calculator. Let's say the older one. There's still a way to do it. It's using table A3. So now I'm going to talk about those, the few that don't have the calculator. I'm going to talk about how to do it on this table. Okay. This is table A3. It's in the formula packet. If you don't have a copy, it's in Canvas. If you're not sure where it is, you can send me an email if this regards to you. Okay, so this has to do with the area of the tails. I'm just going to make it a little bigger so you can see it. Okay. Just waiting for it. There we go. Okay. The area of one tail, the area of the two tails. Okay. One tail is 0.025, the two tails is 0.05. So we look under this part. And then we want to line up with degrees of freedom. Degrees of freedom is 215. Okay, so I'm going to go down here until I get to 215, which is not actually on here, but I'm going to just keep going down here until I get to the 200s. Okay, there we go. I'm going to zoom in here so you can see it better. Okay. I'm just waiting for it to focus. There we go. Okay, so 215 is not on here. So what you have to do is pick the closest number. The closest number to the degrees of freedom of 215 is 200. You can look that up here. It's 1.97, which is pretty close to what we got from the calculator. It's not exactly the same, but it's pretty close. Okay, so again, I will post this entire example in Canvas. And in fact, well, right afterwards, I'll go ahead and post the formula card, just in case if anybody does not have this on your calculator. It is somewhere else in Canvas, but I'll post both of them.